Hi everyone, welcome back to Mindset Matters. If you're into data science, machine learning, or just curious about how data works behind the scenes, this video is for you. Let's dive right into it. Have you ever wondered how AI systems understand text, images, or speech? The secret lies in encoding models. These models transform raw inputs, like words, pixels, or audio, into structured numerical representations that machines can interpret and reason with. Encoding is the very first step that allows AI to learn patterns, extract meaning, and make predictions. What is an encoding model in AI? In AI, an encoding model maps raw data into a vector representation, also called an embedding. For text, this means turning words or sentences into vectors that capture semantic meaning. For images, it means translating pixels into feature maps that describe shapes, colors, and patterns. For audio, it converts waveforms into frequency and temporal features. Think of encoding like compressing reality into a mathematical fingerprint, a representation that keeps the essence of the input while making it digestible for algorithms. Why encoding models matter in AI? Encoding is critical because it 1. Preserves meaning. Encoders don't just store data, they capture relationships and context, for example, king and queen being close in vector space. 2. Enables learning. Machine learning models need structured input. Encoding turns messy real-world data into formats suitable for neural networks. 3. Supports generalization. A good encoder allows models to perform well on unseen data by learning the underlying structure rather than memorizing raw inputs. Without encoding, AI systems would be like trying to understand a novel written in symbols with no translation. Key types of encoding models in AI. Different domains use different encoding strategies. Some of the most important include 1. Text encoding. Models like Word2Vec, GloV, and modern transformer encoders, for example, BERT, map words or sentences into embeddings that reflect meaning and context. Example, bank in the context of riverbank versus money bank gets different vector representations. 2. Image encoding. Convolutional neural networks, CNNs, and vision transformers, VET, act as encoders for images, converting raw pixels into high-level features like edges, textures, and objects. 3. Audio encoding. Models like WAV2Vec or MEL spectrogram encoders transform audio signals into features capturing pitch, tone, and rhythm. 4. Multimodal encoding. Advanced models like CLIP, by OpenAI, encode both text and images into the same embedding space, allowing cross-modal reasoning, for example, matching an image of a cat with the word cat. Encoding in action. A practical example, imagine you're building a recommendation system for movies. Text encoding processes movie descriptions into embeddings, capturing themes like romance or sci-fi. Image encoding extracts visual style features from posters or thumbnails. Audio encoding captures soundtrack elements, like whether the movie has upbeat or suspenseful tones. The system then compares these embeddings to user preferences, allowing it to recommend movies that feel similar, without relying only on metadata. Conclusion: encoding models are the translation layer of AI. They take the complexity of human language, vision, and sound, and compress it into structured, machine-readable representations. These representations fuel everything from search engines and chatbots to autonomous vehicles and generative AI. Mastering encoding models means mastering the foundation of artificial intelligence itself. Next step, I encourage you to explore popular encoders like BERT for text, ResNet for images, or CLIP for multimodal tasks. Experiment with embeddings in your projects. You'll gain deeper insights into how AI truly understands the world. Thanks for watching. If you found this helpful, hit that like button, subscribe for more data science content, and let me know in the comments, which encoding technique do you use most often?